250 kilowatt hours a month, and you pay 12 cents a kilowatt, which isn't too bad. The average is somewhere around 8 cents a kilowatt. The problem in California is, okay, we start off at 12, so it's already quite a bit more, but the more you use, the more you pay. And for most homes that are, over 2,000 square feet and certainly over 3,000 square feet, most of the energy you buy, you're going to be paying somewhere between 28 and 41 cents a kilowatt. What I've done here, and if you have a large home, the vast majority of the energy you're buying is at 47 cents a kilowatt. What I've done here is try to put it in units that people understand, which is, everybody buys, not most everybody buys gasoline, and for the most part, people pay about $3 a gallon these days. In a gallon of gasoline, there's 125,000 BTUs. In a kilowatt hour of electricity, there's 3,412 BTUs in a kilowatt. So I just do the simple math to convert. Well, at 12 cents a kilowatt, if this was gasoline, it would cost you $4.39, which is high, but it's not the end of the world. But when you get in the upper tiers, the equivalent dollars you're spending, somewhere, $15, $17 a gallon is what you're paying in energy equivalent dollars. All right, so your electric rates, especially at upper tiers, are very high. That's why when you do a net zero energy house, you have to be very careful and make sure we are in fact producing as much energy as we're going to be consuming. Otherwise, you could end up with a significantly high bill. Now, if you have propane, there's 92,000 BTUs in a gallon of propane, and somewhere around, most people are paying right now, well, it's maybe a little bit lower, but last summer when I did this, it was about $3 a gallon. So that ends up, when you solve for the BTUs, ends up being $4.29 a gallon. So propane is expensive. And natural gas, which is a much better deal, is about $1.75 a gallon equivalent. Again, this tier structure is based on the PG&E coastal region, and these prices were published in the Chronicle on Sunday. Okay, so just briefly, we'll touch on reduction. With the foam insulations and the insulation verifications we're seeing, and just the fact the Energy Code requires more insulation, we're seeing a lot less heat loss and heat gain due to conduction through your walls, floors, and ceiling. We're seeing tremendous, the new window products are just amazing. The Energy Star windows, which most manufacturers now offer at no additional cost, have a U value of 0.3 and an SHGC of 0.3. So those numbers are, just about twice as good as what you would probably buy even, 7, 8 years ago. I mean, the numbers are just outstanding. Also, starting in 2010, we now have a requirement in California to have fresh air. The thought is the homes have gotten so tight that we need to, in order to provide proper indoor air quality, we now have to have either air-to-air heat exchangers or some way to bring fresh air in. And this is something that's now required. This device here in the upper left-hand corner is an air-to-air heat exchanger. It takes the warm indoor air, blows it through a heat exchanger, and then takes fresh outdoor air, which is cooler, at least in the wintertime, blows it over the heat exchanger and then into the house. So you not only get a supply of fresh air to ensure proper indoor air quality, but you're also, it doesn't have to be conditioned as much. Okay, I mentioned the increases in the lighting efficiencies. Standard incandescent light, it takes 1 watt will produce 15 lumens to get the same exact number or the same number of watts. You get 60 lumens with a compact fluorescent, and the LED lighting, which is evolving quite quickly. The numbers come out right now right about the same as compact fluorescence. Philips has announced a product coming out that is 110 lumens per watt that's supposed to be on the market in early 2010. But anyway, those, you can just see the effect of having more, what's known as high-efficacy lighting on sizing of a PV system. It's about at least a 4-to-1 difference, and lighting is not insignificant when it comes to your total energy use. Appliances is even a better story. 80% of the appliances sold in California are Energy Star. A standard refrigerator, this is a 28 cubic foot refrigerator. The standard uses 1,727 kilowatt hours per year. 10 years ago, this same refrigerator would probably be 1,700 kilowatt hours per year. You buy an Energy Star, which, by the way, doesn't really cost any more, and like I mentioned, 80% of the appliances sold in California are Energy Star, $577 kilowatt hours per year. It's the same for dishwashers, washers, TVs. The numbers just come out great. And again, it doesn't affect the lifestyle of the homeowner or the design of the house with these reductions. And I mentioned verification. With the new energy code, not every house will have to have a blower door test to test the infiltration levels and to meet certain infiltration levels. And not every house will have to have a duct blaster test to test the duct efficiency. But I'm saying most will. With the new energy code, it's so hard to get things to comply. They assume you're already putting in lots of insulation in the walls, floors, and ceilings. They assume you're already putting in basically Energy Star windows. They're assuming you're already putting in a very efficient HVAC system. There's not much left that the energy consultant can take credit for besides HERS inspections and some solar thermal for domestic hot water. Beyond that, there's just not much else you can do. And the great thing about grid-tied solar electric systems for new homes is every system has to be verified for its production. You don't get the rebates until, we'll explain that later, but you don't get the rebates unless the inspections are done to make sure that it's not in the shade and it's installed properly and it's producing the proper amount of energy. Okay, I'm going to talk about this later, but I just want to throw this out here now, is that you'll have different options for putting, in a net zero energy house, you have different options for using electricity for space heating. Standard unitary heat pumps, geo-exchange heat pumps. General Electric just came out with a nice air-to-water heat pump. There's your Mr. Slim type ductless heat pumps that are made by a bunch of different manufacturers. And what's new are the air-to-water heat pumps that are some of the European and Asian products that are unbelievably efficient. And we'll talk about all that in just a second. Okay, so we've gone through the house, and the simple thing again is the conservation. Chances are it's already being done. What we do then to calculate whether or not the house or how to achieve net zero energy is we take the specific floor plan, the exact floor plan for that home builder, and we have a list of assumptions that we made based on doing lots and lots of research on material through the Department of Energy, et cetera, how much energy a building or a house or a room in a house will use based on the square footage. So we take the floor plan and we download it, and then we just have a series of equations we run based on the square footage of each type of room. And what we then develop is a total of the kilowatt hours that are being used for the lights and appliances for that house. When we do that, we then give it back to the homeowner and say, look, here are the assumptions we made. You know, we assume you watch 4 hours of TV and play with the computer 2 hours a day and blah, blah, blah. And we give it back to the homeowner and say, please tell us what you're really average. And they give it back to us. And the results have been great. We've done about 100 projects this way, and we feel very comfortable with our numbers because on a lot of those homes, unfortunately, a lot of the homes had been burned down. So the people had a historical record on a similar house, or the homeowners were building a house similar to the one they just moved out of. You know, it's the same family, just they're moving a few blocks away and building a new house. So we feel pretty comfortable with these numbers that we're close, but we like to have the occupant, go through and see where they think the numbers are going to vary. At that point, we do what we call the previous slide. This slide was for our standard lights and appliances inside the walls of the building. And then we do what we call our non-standard electrical worksheet. And these are things that are either outside the walls of the building, things like swimming pool pumps, well pumps, exterior lighting, hobby use of, who knows what. And also within the house, things like, the guy's running his business out of his house and he has a server and 3 computers, or a kid that plays video games 12 hours a day, or a reef fish